Hello everybody, good evening and welcome to Pisa Presents. Today we're going to be looking at a rather famous fossil group called the Eurypterids. So let us begin. Now, they are better known by their somewhat inaccurate alias of sea scorpions. And while this large and diverse group of fossil organisms were indeed arthropods, they are completely extinct, spoiler alert, sorry, they are not directly related to today's scorpions. They're members of the subphylum Chelicerata, and that is named in honor of the frontal-facing legs called chelicerae right there. Sorry, I have an awful cold. With specialized appendages, which are specialized appendages for catching prey. Now, early specimens appeared in the Ordovician, and the group's extinction altogether came at the end of the Permian, so they were around from about 465 to roughly 250 million years ago. And early on, they were mostly small, with a few species being only even 2 centimeters in size. Now, what are the origins of these early species? And, well, unsurprisingly enough, paleontologists cannot quite agree. Now, did Eurypterids quickly evolve in the Ordovician as some suggest? Possibly, but others prefer a slightly older origin looking towards the Cambrian period. Now, that was a time of great evolutionary diversity, and so it does make sense that the ancestors of what would become such a diverse group as this would arise then with so many other ancestral groups. But having also these still unknown ancestors arrive in the Cambrian, that also too allows for further time for them to evolve some of the later key adaptations that we're going to go into. And then right here, obviously you can kind of see from the sign, is a Eurypterid trackway from Western Australia, and there is a close-up of it coming up, so you can see it right there. So that is just kind of how they look when they're going back and forth on their legs, and also too, some of them make an imprint from their tail. It all depends on the species. Very, very characteristic of each species are their appendages. That is a very, very key thing to tell these apart. Now, the earliest known Eurypterid is called Pterygotus. Not this, by the way. I didn't find a really good picture that I liked of that. That is not this particular specimen. Now, that specimen is named after the Pentaconter, which is basically an early Greek warship, and fossils of that going back over 467 million years have been found in Iowa. And oddly enough, for an early species, it was fairly large, with adults potentially being over 5.5 feet long, which is very counter to you have like the teeny tiny ones in the beginning and then this large one, which actually for quite some time was the largest Eurypterid that we know of. Now, some of these fossils, however, are of juvenile organisms, with those specimens being a much smaller 4 to 6 inches long. Now, early Eurypterids were oceanic creatures, with later species being found in brackish water and some even making the transition to land. This was done through the help of a rudimentary lung structure called a chemoplaton, and interesting word that, but still. And so that is one of the things that they think, most likely, obviously, you need a lung to go on a land, was what allowed them to make that transition. So they were very, very widespread in the water column and are a worldwide occurring fossil. So very, very prolific group here. During the Silurian into the Devonian, most species were still small. They were diversifying based upon changes in their appendages again. And the Devonian, though, is known as the age of fishes for a reason. So fish really, really started to get big in the Devonian, no pun intended. The evolution of the fish came about really around this time and really just started to rise up. And the large bony fish called the placoderms, you have a close-up on the right there, would have posed a threat to many a species in their time. So was it this competition and a need for defense that drove the rise in size for the Eurypterids? Probably. Now, this right here is Pterygotus, the Gondwana giant. This fellow was over 8 feet long, a lot of people theorize. Best guess, 8 to upwards of 9 feet. Some people even say more than 9 feet long. Now, these large species came about the Devonian into a little bit later. Now, a lot of the adaptations that the group had already had allowed for this increase in size and allowed for them to still be adaptable and maneuverable. I mean, they had a hard chitinous exoskeleton, but still they had jointed appendages, so you were able to move back and forth very readily. And these later large species had a paddle-like tail called a telson. You can kind of see a little bit of a hint of it in the back there from where the fossil is depressed. Now, that acted as more or less a paddle, and it made these later large Eurypterids very strong swimmers and the apex predators of their day. And in terms of their claws, just take a look at the claws up front there. Now, like some scorpions today, a few species of large Eurypterids have been found to actually have metal in their claws. Now, I'm not quite, not talking about Wolverine here. We're not looking into adamantium. We actually mean zinc. Several species had claws lined in zinc. We've been able to figure that out. And so most likely this was done to give these species extra crushing strength now that they were being faced by these additional species, additional possible predators in their midst. And speaking of potential predators, we know that some species cannibalize their own. So yes, proper defenses were very necessary in order to protect them from their own kind as well. Now, another key adaptation was that some had eggs, whereas others had live young. Now, you can just see right here, this is a look into some of the larger ones that we have. So the Pterygotus one that was mentioned earlier, that one is on the far left, and that is a terrible illustration of a human. That just looks like, that is just total nightmare fuel right there. That thing looks awful. So you have the Pterygotus right there, and then a couple of the other ones going all the way up to the largest one that we've found yet is on the right-hand side. So that just gives you a look into some of the ranges of sizes that we've had for some of these. Now, all the same, size or not, the group took a very, very heavy hit at the end of the Devonian with an extinction then. And the remaining species were, for the most part, all just these large ones, most likely because they were the ones that could survive the attacks from the armored fish the best. Now, some later, and perhaps even early species, may have had a rudimentary form of camouflage. Nothing too ornate, just like this little fellow right here. Microstructures within some of the fossils indicate a model coloring pattern of light on the bottom and then that dispersed top. Basically, the idea is that if somebody is logically swimming on top of them and they look down below and they're like, that looks kind of yummy. If it has that model coloring, it would kind of blend in with the rock or whatever subsurface is down below. A lot of these species, too, also had defensive spines. And, however, though, all this could really it could only do so much. And as the fish got more and more and more prolific, increased competition and predation is most likely what led to the extinction of the Eurypterids, with Campylopcephalus being most likely their very last species around. Now, altogether, there's still a very famous fossil locally. A lot of them are well known in New York and other regions in the tri-state area. Encourage you to go out and find them. Although they're very prolific, they're not the sort of thing that, honestly, I see people collect that much, and that's a shame considering the amount of species that people have that are out there that you can really find. So, thank you very much. Go out there and, go find yourself some sea scorpions now. Bye.